You can't actually do PROFIBUS to RS-485 conversion the way most people picture it. There isn't a direct conversion that makes an RS-485 device suddenly become PROFIBUS I/O, but you can build an architecture that behaves like conversion from the PLC's point of view, and once you see the data flow, it becomes really straightforward. In this video, I'll be showing the block diagram, how the bytes map, and the detail that determines whether it's stable. Then we'll implement it using a PROFIBUS DP slave to serial gateway, in our case, the ICP-DAS USA I-7550-B. Now, when engineers say conversion here, what they usually want is simple. The PLC is on PROFIBUS DP, the device is on RS-485, and they need predictable data exchange, reads and writes, without redesigning the entire system. The key idea is that PROFIBUS is the network the PLC speaks, and RS-485 is how the serial device is wired. And what determines whether this is stable or not is the fact that it's RS-485. It's whether you treat the serial side like a request and response transaction with timing, buffering, and validation, or whether you treat it like, we'll just send bytes and hope that it works. If you do it the first way, it'll run for years. But if you do it the second way, it becomes one of those systems that works on the bench and then randomly misbehaves once it's in the field. So in order to implement this architecture, you need a module that shows up as a PROFIBUS DP slave and gives you a serial interface on the other side. We'll use the ICP-DAS USA's I-7550-B as the example hardware so you can see the full setup end to end. The I-7550-B is a DP-V0 slave. It supports the standard PROFIBUS transmission rates up to 12 megabytes, and the PROFIBUS baud rate is detected automatically. On the serial side, it's the hybrid COM design, so it supports RS-232, RS-422, or RS-485, but you choose one mode at a time. But in this video, we're just focusing on RS-485. So before you wire anything, you want to confirm the serial settings the device requires: baud rate, parity, data bits, and stop bits. The I-7550-B supports common serial baud rates up to 115,200 BPS and typical serial formats like 7 or 8 data bits with none, even, or odd parity. If your settings don't match the device, nothing else you do will matter. Now, wiring is simple, but there are two areas that cause most of the wasted time. First is PROFIBUS termination. Make sure the segmentation is terminated correctly at the ends of the trunk. Second is RS-485 polarity. Confirm your data plus and data minus match what the device expects, and follow your standard practice for reference and grounding based on your installation. Next is PROFIBUS addressing. Set the station address on the gateway and match it to your PLC hardware configuration. The I-7550-B address range is 0 through 126, and it's set by DIP switch, so once it's set, label it and keep it consistent with the PLC project. Then add the module as a DP slave in your engineering tool, set the I/O length you plan to use, download the configuration, and confirm the network goes into the normal data exchange. Now on the module itself, you've got status LEDs for power, run, and error, which makes it easier to see when you're in a healthy state versus a configuration or network issue. Now, for the part that actually makes conversion work, a clean way to think about it is that the PROFIBUS outputs from the PLC are your transmit buffers going to the serial side, and the PROFIBUS inputs back to the PLC are your receive buffer coming from the serial side. The I-7550-B supports up to 128 bytes of input data and 128 bytes of output data on the PROFIBUS side, so you have plenty of room for most serial message formats. The PLC builds a request into the transmit buffer, triggers the send, waits for a response or a timeout, validates that the response is complete and makes sense, and then parses it into real values. This is what prevents the common symptoms like shifting bytes, partial responses, or data that looks right one cycle and wrong the next depending on scan timing. A common example is adding an RS-485 meter or instrument. The PLC wants a few values periodically. Over PROFIBUS, you're just moving bytes in and out, but your PLC logic is what turns it into a reliable request and response exchange. Once you've got that structure in place, it behaves like any other part of the PROFIBUS system from the PLC's perspective. So that's what PROFIBUS to RS-485 conversion really looks like. A PROFIBUS DP slave to serial bridge, mapped bytes, and a simple but disciplined request and response structure in the PLC. If you have any questions regarding any of the things that we covered in this video, please don't hesitate to comment what your RS-485 device is. Modbus RTU or vendor specific and what PLC you're using. We can point you towards a clean buffer layout and a troubleshooting approach that fits that setup. And if you think that this kind of integration walkthrough is useful, please remember to like the video and subscribe so that we can know to keep making videos just like this one. Thank you so much for watching this video, and if you have any deeper questions, you can always reach out to our team at sales@icp-usa.com, or you can head straight over to our website at icp-usa.com. Now, if you're interested in checking out this module, we actually have a link in the description below that will take you straight to it. And again, just as a reminder, if you do want to check out this product for yourself, the link will be in the description below.